Okay, now we're going to start I1, Introduction to Complex Numbers. Complex numbers are also called imaginary numbers. And we'll figure out what imaginary numbers are in just a little bit. So, if I have 5 squared, what does that mean? It means 5 times itself, which is 25. And if you have negative 5 squared, with the negative on the inside, that's very key right there, negative on the inside, that means negative 5 times negative 5, which is 25. So if I do a positive 5 times positive 5, I get 25. And if I do negative 5 times negative 5, I also get positive 25, right? Okay. So that's whenever you are squaring. But what happens if we want to undo the squaring? I am going to, just a second, I'm going to kind of, wish I had white. Oh, looky there. Let's make it big. Okay. Let's go back to black, go back to thin, and we'll do the square root of 64 over here. So I have a little bit more room to work. Okay, so what this means is the square root of 16. What did you multiply by itself to be able to get 16? What times what is 16? And yes, the answer would be 4. But if you recall, just for a second ago, if I got a positive 25 by multiplying 5 times 5, and I got a positive 25 by multiplying negative 5 times negative 5, then if I am undoing it, and I'm taking the square root of 16, 4 times 4 is 16, but also negative 4 times negative 4 is a positive 16. So the square root of 16 can be either 4 or negative 4. So on this one, whenever it's asking the square root of 64, what do you multiply by itself to be able to get 64? 8. But you can also multiply 8 by negative 8 by negative 8 and still get a positive 64. Alright? Okay. So if you're taking the square root of 16 and 4 times 4 is 16 and negative 4 times negative 4 is 16, and the square root has to be the same number times the same number, you can't take the square root of a negative number. So we will take it out of the radical. So what I'm trying to say is, if I'm asking you to take the square root of 16, and the square root means the same number by the same number, what times what will give you a negative 16 when they are exactly the same number? Well, you say 4. No. 4 times 4 is positive 16. Okay, you say negative 4. Negative 4 times negative 4 is positive 16. Or okay, you say 4 times negative 4 is negative 16, right? But these have to be the same number. So there is not a number that you can take the square root of and get a negative answer. Okay? You can't take the square root of a negative number and get an answer. But we have to be able to do these problems in math to be able to get answers that we need to get. So here's what we're going to do. So we're going to take the negative out of the radical. So if I give you the square root of negative 16, we cannot do this. Okay? So we are going to change it to this, and that is an I. Okay? It's an I because it stands for imaginary. This number did not exist for anything that we could possibly have ever known to do. And so we're going to take the negative out, and the negative tells us that it's imaginary because the negative is inside the square root. So we take the negative away, we make it an I, and now this is a positive square root of 16, right? So it's going to be 4i. Now, I know you say, well, what about negative 4i? Because we already took the square root of 16 a while ago. Just kind of bear with me. And if we're just simplifying, if we're just simplifying, then you don't worry about a positive number or negative number. You just, whatever the problem says to be. Okay, so here we are. I'm going to rewrite this. Okay. This negative is fine because it's on the outside. This negative is bad because it's on the inside of the square root. That negative is going to become this right here. So negative square root of 10 and then the I. Now, here's the deal. I am going to put the rest of this, I'm going to have to start, I'm not going to start over because I've said a lot of stuff and I've already been doing it for 6 minutes and 20 seconds. But I'm going to stop right there because the way that I'm recording this, I can't share any screen except for this. So I'm going to stop there and I'm going to pick this problem up in just a second. So go on to the next video for I1 right now.